everybody. It is day 3 math. You need to grab the packet that says day 3 and a pencil. A colored pencil if you have it, or a crayon would be helpful. Please put your names on top. Today we're going to use the area model and multiplication to show equivalence between two fractions. All right, so let's start off. Problem number 1. Let's draw an area model. And let's break it down into thirds. Let's very lightly shade in 2/3. At any time, if I'm going too fast, feel free to pause the video. So I'm dealing with the fraction 2/3. Now what I want you to do is draw 3 horizontal lines across the area model, and we're going to dot them. So 1, 2, 3. So what happened to the size of the fractional units? Well, this one is 4 times as small because we divided each unit into 1, 2, 3, 4 smaller units. What happened to the number of units? Well, we started with 3. Now there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 4 times as many units. What happened to the number of selected or shaded units? We started with 2. Now we have 1, 2, 3, 4, 5, 6, 7, 8. So how could we represent an equivalent fraction? Well, we started with 2/3. Now we have 1, 2, 3, 4, 5, 6, 7, 8 shaded out of 9, 10, 11, 12. We could show how we did this by using multiplication. And we could multiply the numerator and the denominator by 4. So what I do is take 2 times 4, and I take 3 times 4. 2 times 4 is 8. 3 times 4 is 12. How do I know the fraction is still representing the same amount? Well, I didn't change. I didn't shade in more blue. I didn't erase. It's still the same amount. Now, there might be smaller units instead of a few bigger ones, but this area stayed the same. So I just proved that 2/3 is equal to 8/12. All right, problem number 2. Let's write down the number sentence 3/4 is equal to 6/8. Now, if the whole is the same, is this statement true or false? Well, if I thought to myself, 3 times what is 6? It's 2. And what times 4 is 8? It's 2. As long as you multiply the numerator and the denominator by the same digit, you can make an equivalent fraction. Now, I can show this in my area model. For those of you who don't believe me, first I'm going to show 3/4. to go from 3 shaded in to 6 shaded in, I have to draw one horizontal line. Now I have 1, 2, 3, 4, 5, 6 out of 2, 4, 6, 8. This model proves that that's true. I didn't have to shade in more, erase any of my blue. They're there. Now, if you multiply the numerator by a different digit than the denominator, that's not going to become true. For example, if I had 3/4 and I wanted to prove that it's equal to 6/12, I know that 3 times 2 is 6. 4 times 3 is 12. Since I used a 2 with the numerator and 3 with the denominator, they are not equal. It has to be the same number. So, let's go on to problem number 3. I'm going to go to the back of this page. Let's write down the fraction 3/5. Let's not draw the area model yet. Let's come up with an equivalent fraction. Now, when I do this, you can use any number. You could use 1 billion if you wanted to. But I like to keep the number smaller when I can because I'm better with those math facts. And if I have to draw an area model, then I don't have to, draw one that's absolutely humongous or lots of lines. So I'm just going to pick 2. Just remember the rule. If you multiply the numerator by a 2, you must multiply the denominator by a 2 when making equivalent fractions. So 3 times 2 is 6. 5 times 2 is 10. So I just proved that 3/5 is equal to 6/10. Now, can I show that with an area model? Absolutely. I started with 3/5. I multiplied it by 2, which means I'm going to draw 1 horizontal line. And I have 1, 2, 3, 4, 5, 6 for my numerator out of 7, 8, 9, 10 for my denominator parts. How do I know they're equal? I didn't add any more blue or erase any blue. So we just used multiplication and the area model to prove equivalent fractions. Let's turn to the problem set. Okay, so I am going to have you do all of problem number 1. A has been done for you. You're going to do B, C, and D. And then you're going to do number 2, A and B. Flip to the back. You're going to do number 3, and I want you to do, how about if you do A and D? In this one, you're just going to use multiplication to rename these fractions. So do number 4, all the parts. And I want you to do number 5, and we will do a couple of these together right now. It says, determine which of the following are true number sentences. Correct those that are false by changing the right-hand side of the number sentence. So we have to prove if 4/3 is equal to 8/9. So I'm going to rewrite it. All right, so 4 times what is 8? It's 2. 3 times what is 9? Oh, that's 3. So, because I used different numbers to multiply, this is false. So I'm going to put an F there for false. How could I make an equivalent fraction? Well, once again, I'll multiply by 2. 4 times 2 is 8. 3 times 2 is 6. That one works. So if it's false, you have to make one that is true. Let's check out C. We have 4/5 that we're turning into 12/10. Four times 3 is 12. 5 times 2 is 10. Oh, different numbers. Those are false. So you go ahead and make it into an equivalent fraction. And you're going to do that for B and D if they're false. If you do the work and it's true, then you just say true and you're done. If you're having any problems with this, don't get frustrated. Remember, this is new. Feel free to message me, and we're going to go over all of this when you come back to school on Thursday.